Hello, good morning. Good morning. Are you able to hear me? Hello, are you there?
Morning teacher, tunakusikia. Morning.
Oh, thank you. I hope you are doing well. I'm sorry. I'm late due to some inconveniences that I had on the way, but I hope we are able to recover that. So I have been told that last time you discussed about the area of plane figures. So today I want us to look at volume and capacity, unless there's anyone with something concerning area before we proceed to volume and capacity. What could you say? Is there anything that you may want to revisit or?
No, we are okay. Just proceed.
Okay. So when we talk of volume, it usually entails finding the amount of space occupied by a substance or an object. And we all know that volume is simply given in cubic units. So you can be able to see. So for example, if you are to find the volume of a cube, you will only need to have
Teacher, a point of
to find the
interruption
cube.
kidogo.
Yes.
Yeah, yesterday we learned about the volume ya cubes na cuboids na cylinders. Yeah, hata tukapewa assignment.
Okay.
Ama you are just, ama you are just unapitia. Jana tulifanya hiyo.
Oh, so I'm supposed to start from capacity.
Yeah, I think
Is
so.
it?
Kwa sababu tulishapewa assignments. Yes, we have the assignment to do.
Oh, I thought I was supposed to start volume. It's okay. So we can begin from capacity. Hello. Yes, I'm sorry. I got some interruption here. I hope now I'm okay. You are able to hear me.
Yes.
Yeah. Fluids, and its SI unit is given in liters. So when we talk of capacity in simple terms, we are talking of fluids, and when we talk of fluids, we are referring to both liquids and gases, and it's usually, or they are usually measured in liters. So we have the conversion of units of capacity here, whereby the first thing is 1 centiliter is equivalent to 10 milliliters. That one as the relation that you can be able to use to convert those units. So those are some of the subunits that we have in liters. But now there are these other ones whereby we can be able to convert now liters to meters cubic, or from meters cubic to liters, and also from centimeters cubic to liters. For example, in this case, we have that 1 liter will be equivalent to 1,000 centimeters cubic. That's when we convert liters to centimeters, because I'm assuming that we already know now how to find the volume. Then another one is that 1 meter cubic is equivalent to 1,000 liters. So therefore, this is the other units that we can be able to use, or that are commonly used in capacity. So I want us to look at the first examples that we have been given here. Like now in exercise 14.24, we have that expressed in liters, and then we have been given 400 milliliters. We need to write it in liters. So as you can be able to see here, is that if we are taking liters as the reference point at this point, taking liters as the reference point, so meaning that everything that is above these liters, like now, for example, 1 liter here, when we want to to have it in deciliters and milliliters, so in that case, it means that we are going to have it that 1 liter will be equivalent to 1,000 milliliter, as you have been given here. So using that relation, we can be able to convert this 400 milliliters into liters, whereby when you cross multiply, you are simply going to have 1 liter times 400 ml divided by 1,000 milliliters or ml. So meaning that the ml will be able to cancel, and then in this case 1,000, it's 2 zeros, will be able to cancel with that one, so that we can be able to remain with 0.4 liters. So meaning, in short, we are supposed to understand this table here so that we can be able to use it to carry out the conversion of these units. The other example that you can be able to see here is this one here, which is of hectoliters, or the hectoliters. Whereby, for example, you have a question like this 375 hectoliters. Who can give us on like what we are supposed to do in this case? In that case, who can give us an idea on what we are, or how we are supposed to go about it using that table? Someone? Yes, anyone?
Let me try. I think. Do you get me, sir?
Sorry?
I think we shall first change because you have been given in hectoliter. We shall
Yes.
first change to deciliter, then from deciliter to liters.
Mm-hmm. So how will it be in deciliters?
We shall say 1 hectoliter is equals to 10 deciliter. So what about 375? To get the deciliters, then we shall convert. I'm not yet done in the book, but I think that's the way.
Okay, thank you. And anyone else with another idea? Anyone else? Okay. So here we can be able to do that, or the other way is that there is a certain formula I had whereby it simplifies these units, whereby, for example, we can be able to say that so this one is a simple formula whereby we can be able to say that Kofia huuzwa dukani mwa Daudi senti mia, such that this K stands for kilo, so meaning that it will be kiloliters. Then this other one will be hectoliters. Then this other one becomes decaliters. Then this one will be milliliters. Then this other one becomes the deciliters. Then this other one becomes the centiliters. And then we'll be able to have the other one here becomes the micrometers, the last one here, but we will not be able to use that one, the microliters. So therefore, at this point whereby we have the milliliters, we'll be able to have liters at the same point here, because we'll be able to understand that this one here, milliliters, is equivalent to 1,000. Sorry, I mean 1,000 milliliters is equivalent to 1 milliliter. So therefore, meaning that this one here becomes 0.001 liters. Then this other one here, the decaliters, we know that it will be equivalent to 10 liters. Then the hectoliters will be equivalent to 100 liters. And then kiloliters will be equivalent to 1,000 liters. Then this other one here, the deciliters will be equivalent to 0.1. Then the centiliters will be equivalent to 0.01. Then lastly, we'll be able to have this other one here as 0.001. So these are the units that we can be able to use, whereby at this point, wherever we have milliliters, this M here, we can replace it with ought to be liters, so that it becomes the reference point. Though I don't know whether that one could be effective for us to use, whereby now, once we have it this way, it means that for us to convert 375 hectoliters to liters, we simply use this one here, whereby we know that 1 hectoliter is equivalent to 100 liters. So therefore, it becomes easier, whereby when we say that 1 hectoliter is equivalent to 100 liters, how about 375? So when you cross multiply, you will simply have 375 times 100, then divided by 1. So therefore, your result becomes 37,500 liters. So we can either use this.
I have a question. Teacher, I have a
Yes,
question there.
yes,
Yeah, before you continue, on that
yes,
table that you have done for us, we have 2
yes.
ml. The first ml is okay. The first one milliliter. What about the last ml? Is it also a milliliter?
This one here, I have said the first one here, this one, I say that we can replace it because this is the unit that is used in length. So, but it can also be able to apply in capacity, whereby in length, this M stands for meter, which in our case here, we can replace it with L instead of M, so that now this one becomes the reference point. So meaning that at this point, we'll be able to have this capacity at this point to be such that if it's L, yeah, this at this point, if this one is as L now, it becomes the reference point. So meaning that it will still be equal to 1. So meaning that as you move up from L upwards, it increases by 10, 10, 10. And then as you move downwards, now it becomes divided by 1 over. So meaning that this one here can be written as 1 over 10. This one here can be 1 over 100. Then this other one becomes 1 over 1,000. Yeah, so this becomes the milliliters. And then this becomes the centiliters, this deciliters, and then this liters now becomes the reference point. So it's the starting point. Remember, this first D becomes the capital D, standing for decaliters, and then this small d stands for deciliters. So you should not confuse between the two.
Okay.
Yeah, so you can choose either to use this table or the other one, whereby it's a formula that I was given in primary. I think I can be able to remember it up to now, whereby K stands for kofia, then H stands for uhuzwa, then this other one, D, stands for dukani, then this one here now, L, we were using it for length, whereby it was M, mwa. Ama in this case now we can use duka or dukani, la, Daudi, senti, mia instead of mwa. In this case now we can use la, dukani la, Daudi, senti mia in easier terms for you to master that formula. I hope that one is well understood.
Yeah, it's clear. Thank you.
Yeah, that one will be more easier than the ones that we have been given here. But if at all you can also be able to cram this one that is provided, it will be okay. So let's look at question 3. Question 3, whereby we have it that a cylindrical container can hold 12 liters of liquid. If the height of the container is 0.4 meters, find its radius to 1 decimal place. Can you please try that one on your own? Then we will be able to revisit it and see how it's supposed to go. So I give you at least 1.5 minutes. You attempt it and then we'll do it together. Yes, let's try it. Are we making some progress? Hello, are we making some progress or should we do it together?
We're trying to do it, but can we do it together? Then you show us that example, then you give us another one.
Okay, for this one, there are two ways in which you can be able to have it done. The first one, you can be able to see you have been given the capacity in liters. So using these units that you have been given here, yes, using these units that we have been given here, this one here, we can be able to convert the capacity into volume, whereby we know that 1 meter cubic is equivalent to 1,000 liters. So we convert this 12 liters into meters cubic. So 12 liters in meters cubic will be equivalent to 12 times 1 divided by 1,000, which is equivalent to 0.012 meters cubic. So now this becomes the volume of that container, or the volume of that cylindrical container. And then we have been given the height of the container being 0.4 meters. So we are required to find the radius. So we say that volume of a cylinder is given by pi r squared times h. Pi r squared times h. So we already have the volume, which is 0.012 will be equal to the pi, which is 22/7, times r squared times 0.4, which is the height. Then once you are at this point, now you can be able to have it such that since we need r, we're able to have it as r squared. You multiply the reciprocal at this point here and also on the other side. I mean, you multiply the reciprocal of 22/7 on the right hand side, and also you do it on the left hand side. So we are going to have it on the right hand side. It will be able to cancel, so that we remain with 0.1, sorry, 0.012 0.012 times this. The reciprocal of 22/7 is that you flip such that the numerator becomes the denominator and the denominator becomes the numerator. So this one becomes 7/22. Then times, on the other end, the reciprocal of this one also becomes 1/0.4. So meaning that we simply have this part here being r squared is equals to 0.012 times 7 times 1, then all over 22 times 0.4. Can you do that one and give me the answer from your end? Get the value of r squared. 0.012 times 7 divided by 22 times 0.4. So give me the value of the numerator. The numerator becomes 0.084.
Yeah, 0.084.
What about the denominator? 22 times 0.4 gives us
8.8.
8.8. So can you divide now? 0.084 divided by 0.8. What does it give you?
9.5454 recurring.
9.5454. So meaning that it keeps on repeating 5454. So now find the square root in both sides. So you find the square root of r you also find the square root of r on this other side. So what would be the square root of that? So r will be equal to
3.0895.
3.0895.
Yes.
Yeah, so now since the question says that you give the radius in one decimal place, so you have to round off this one, whereby when you round 3.0895 into one decimal place is at 0 here. So you stand at 0 and then you look at the number that is next to the 0 in the right hand side. If it's 5 and above, we are going to add 1 to this 0 and then we drop the other. So it means that since 8 is more than 5, so our R will be equal to 3.1 meters as the radius of that cylindrical container. And then that one becomes your solution for that case. So the first thing that you can be able to see in this case is to convert the capacity which you have been given in liters into meters cubic or centimeters cubic. Then from there, you use the formula of finding the volume of a cylinder. Then from there, now once you have gotten the volume or the formula, then from there you can substitute the values that you have been given. In this case, you have been given the volume and then you have been given the height. So you are required to find the radius. And since you know that pi is a constant, which is 22/7, or you can be able to use the other one, which is 3.14. Still to be able to give you the correct answer. I hope that one we are good or we are okay with that. Then the other thing or the other concept I want us to look at is this one when you have been given the capacity or the volume in centimeters cubic, millimeters cubic, or decimeters or meters cubic. For this case, there is also another way in which you can be able to do it. Majorly, we will be required to convert the units to either centimeters cubic, then from there we can be able to, or it will be easier for us to convert it to liters, or we convert to meters cubic, then from there we convert it to liters. For example, let's look at a case like in E, number 2E, whereby you have been given the volume in 3,400 cubic millimeters, and you are required to have this one or to express this one in liters. It will be hectic if we go ahead to use this one in conversion unit of directly into liters from millimeters. So the best way to do it is we can convert it either to meters, centimeters cubic or meters cubic. Then from there we convert to liters, whereby we know that 1 centimeter cubic is equivalent to since this one is okay, I want to explain it in a simpler way. For example, we know that 1 centimeter is equivalent to 10 millimeter. Now, since this one is in cubic, we know that we'll be able to cube this side and also cube this other side, such that now we are going to have 1 centimeter 1 cubic centimeter will be equivalent to 1,000 cubic millimeter. So therefore, now this becomes the unit that we can be able to use to convert this one to centimeters cubic. So when we convert this one, meaning that 3,400 millimeter cubic can be given in centimeters cubic, such that now we have it in 3.4 centimeters cubic. Then from there, now we can use this unit here, which is 1 liter is equivalent to 1,000 liters. How about, sorry, I mean 1,000 centimeters cubic. How about 3.4 centimeters cubic? So when you use that, you will be able to have, in terms of liters, it will be equivalent to 3.4 divided by 1,000, which is 0.0034 liters. So that is the easier way in which you can be able to do it. Or you can decide to convert it to centimeters. You convert the millimeters to meters cubic, though that one is going to be still giving you the same result. For example, if we can be able to use it, we'll be able to say, like in this case, we know that 1 meter is equivalent to 1 meter is equivalent to 0. Is it 0.1 or 0.01? We'll be able to have it in meters. So we know that 1 meter is equivalent to it's 0.01. Sorry, you have 0.01 millimeters. So meaning that if we are to cube both sides, we cube here, we also cube on the other side, we'll be able to have this one as 1 meter cubic will simply be equal to 0.0000001, or in simple terms, it can be equivalent to 1 meter cubic is equivalent to 1 or over a million millimeters cubic on this side. So meaning that when you use that one, you simply have, what about the 3,400 cubic millimeters? So when you have that one, it means that you will be able to have 3,400 divided by a million. So when you divide that, you simply have these 2 zeros and 2 zeros cancelling, so that you'll be able to have your answer as 0.0034 millimeters cubic. Then from there now, you can convert this one to liters, whereby we know that 1 liter, 1 meter cubic is equivalent to 1,000 liters. How about 0.0034, whereby that one now becomes 1,000 times that, it gives us 3.4 liters, which is the same as what we got at the first case. I hope that one is correct. Is that okay?
Yes, but can you do another example? The last one.
Okay. The other example, we can pick a question like number 2F. Can pick number 2F, which says that we need to express 170 decimeters cubic in liters. So we have 170 decimeters cubic, and we are required to express that one in liters. So therefore, the first thing that we have said here, is to convert this decimeters cubic into meters or centimeters. So whereby we already know that 1 meter is equivalent to 0.1 decimeter. So we say that we can cube both sides, so that now this one becomes 1 cubic meter is equivalent to 0.001 cubic decimeters. So how about 170 cubic decimeters? So at that point now, when you convert that one, it means that you'll be able to have 170 decimeters times 1 divided by 0.001. So therefore, that one becomes cubic meters. 170,000 cubic meters. Then from there now, we can be able to convert that one into liters, since it's already in cubic meters. So whereby we know that 1 cubic meter is equivalent to 1,000 liters. How about 170,000 cubic meters? It will be equivalent to how many meters? So that when you cross multiply, you are going to have 170 million liters. That one becomes now the final answer, which is 170 million liters. I hope that one is well taken.
Yes, understood.
Yes. Now can you attempt this one? 20. We have 20. Yes, convert that one or express that one in liters. The 20 decameters. Yes, attempt it. Yes, I can see your answers here. One is 20 million liters and the other one is 200 liters. Okay, so let's look at it and see what we required in this case. We know that 1 meter is equivalent to 10 decameter. So when we cube this one, this side here, we also cube this other side here. It becomes 1 cubic meter is equivalent to 1,000 decameters cubic. So therefore, at that point, we'll be able to have it as 20 decameters, 20 cubic decameters will be equivalent to how many? So when you cross multiply, you simply have 1 times 20 divided by 1,000. So therefore, this one will be equal to 0. To be equal to 0.02 cubic meters. Then from there now, when we convert this one into liters, we'll be able to have that 1 cubic meter is equivalent to 1,000 liters. How about 0.02? So when you cross multiply, you simply have 0.02 times 1,000 liters, whereby we get 20 liters as the final or as our solution in that case. I hope that one is well taken. Is it? Are you together in that?
Why have we started? We had ulikuwa umetuambia we convert the 20, is it decameters?
Yes,
Liters?
decameters into cubic meters.
Oh, 2 cubic meters.
Yes. Then from there, from cubic meters to liters.
Okay.
Yeah. Or the other way, we say that you can convert the decameters into centimeters, then from centimeters into liters. So again, we can attempt our next question, which is on, let's have it as a 300. Attempt that one.
Teacher, unakatika usikiki namba ngapi? Oh. Okay. We are converting 300 hectometers to
Are you done? Again, a sim. Are you done?
Teacher. Hi, teacher.
Yes. Yes.
We were converting the 300 to what?
Sorry.
We were converting the 300 hectometers to?
We say that the first step is to convert it to meters cubic. Then from there you convert meters cubic to liters.
Okay.
Yes.
Then I have a question, Mwalimu.
Yes.
Yeah, I think I wrote badly. We said 1 meter cubic, is it 0.01 or 0.1? I mean 0.01 or 0.001.
Converting it to. I haven't gotten your question well. Come up again.
I'm saying 1 meter cubic. I think I didn't write vizuri. 1 meter cubic, is it 0.01? I mean 0.001 decimeter cubic ama ni 0.01 decimeter cubic?
Ni 1 meter ni decimeter, 10 decimeter. Then you convert to cubic, you multiply by 30.
Hebu come again. I think niliandika vitu mbaya.
1 meter
Yeah.
is equal to 10 decameters. Then 1 meter cubic is equal to 1,000 decimeter cube. Then you make 1,000 decimeter cube.
One
Then
meter
from
cubic.
there,
Angalia Domi. 1 meter cubic is equal to 10 decimeter cubic, si ndio?
hapana,
Eh.
to 10 decimeter then ukitaka kuifanya cubic, sijui kama niko correct, 1 meter cubic is equal to 1,000. You multiply ifike to cubic. Ikuwe
I think
1,000 decimeter cube.
si mwalimu basi atufanyie clarity. Juu mimi naona niliandika vitu. Maybe are you right ama are you sure ama
So I don't know. I got some hiccup here, but now I'm back. I hope we are able to hear me now. Are you? Are you able to hear me?
yes.
Yeah. What was your question, Domi?
Ni Monica, uliza.
I was asking. Okay, mwalimu kuna mali hapo nilikuwa sijashika vizuri. As in kwangu nilikuwa nimeandika 1 meter cubic is equals to 0.001 decimeter cubic. Is it right? Ama juu naona nimetumia hiyo nikakosa. I didn't get to that right answer Fazili.
Okay, let me just revisit that table. You see, I said that this table can be used in both length and also in that of capacity, whereby we say that we have K at the top, then followed by H, then capital D, then M, then we have a small d, then C, then M. Whereby we say that if it's in length, we are going to add M to each letter here. M, except at this point we don't add M, then this one becomes that one, Evo. So therefore, this one here will be in kilometers, hectometers, decameters, then meters, decimeters, centimeters, and millimeters. So therefore, we say that now this one, if we start from meters, this one will be equivalent to 1 meter. Then when you move upwards, it increases by, or you multiply it by 10. So meaning that this one will be 10 meters. Then this other one will be 100 meters. And then this other one here becomes 1,000 meters. Then when we move now downwards, this one will be divided by. So we divide by 1/10. Then this other one becomes 1/100. And then this other one is 1/1,000. So when you look at this one, when you write it as a decimal, in is the same as 0.1. Then this other one is 0.01. Then this other one is 0.001. That is 0.001. So therefore, those are the units that you can be able to use. Then we say that when it comes to capacity, we change this point here. This part here, it becomes L at this point. And then these other ones, wherever we have placed M, we place L. Now this one becomes kiloliters, hectoliters, decaliters. Then this one we retain it as L. Then this other one becomes deciliters, then centiliters, and then milliliters. But the values here remains. It will remain to be the way they are. 1 liter at this point now, you're able to also have this unit here in liters. So therefore, this one now becomes 1 kiloliter is equivalent to 1,000 liters. 1 hectoliter is equivalent to 100 liters. 1 decaliter is equivalent to 10 liters. Then this other one here, since it's liters, so it's 1 liter is equivalent to 1 liter. And then 1 deciliter is equivalent to 1 over 10 liters or 0.1 liters. Then the other part is 1 centiliter is equivalent to 0.01 liters. And then 1 milliliter is equivalent to 0.001 or 1 over 1,000 liters. Or you can be able to exchange it such that now we can have it this way here. You see this one downwards. Instead of us starting with this part here, we can have that 1 liter is equivalent to 10 deciliters. Then 1 liter also is equivalent to 100 centiliters. And then 1 liter on this other end is equivalent to 1,000 milliliters. So unaweza reverse such that ukifika liters downwards, una increase by, or you multiply by 10 as you move downwards. And then on this other side, this one becomes 1 kiloliter equals to that one. So it's you to choose which one is easier for you. If you see it's easier for you to work with the decimals, you can use that one. Or if you find it difficult for you to work with the decimals, you can have this side to be in 1 liter, 1 liter, 1 liter, and then this one here, you multiply by 10. So 10 deciliter is equivalent to 1 liter. Then 100 centiliters is equivalent to 1 liter. And then 1,000 milliliters is equivalent to 1 liter. So that one will be easier for you to interpret so that it becomes simple for us to solve those questions. So now using this one for solving that question that I had given, 300 hectoliters, we can be able to have this one in meters as we had said. So we will know that 1 hectometer is equivalent to 100 meters. Then we cube here, and also we cube this other side, so that now we have 1 hectometer cubed is equivalent to 1,000,000, which is also written as 10 to the power of 6 meters cubic. So therefore, that means that when you can be able to use that one to convert the 300 hectometers cubic, you'll be able to have your solution as so that one becomes now 300 million meters cubic. Then from there now we know that 1 meter cubic is equivalent to 1,000 liters. How about the 300 million liters? So when you convert that, it means that you are going to multiply. So it means that it's going to be equals to 300 billion liters. Yeah, I hope that one is well understood. Is it?
Yes. Yes, now.
Yeah. Yeah, so you can be able to manipulate that table to suit your question that you are required to handle. So maybe we can do another example here, which involves now the cuboid. Number 5, which says that find the width of a room which is 8 meters long and 5 meters high if it contains 120 cubic meters of air. For that one, we know that the volume of a cube or a cuboid, is given by length times width times height. We have been given the volume being 120 cubic meters. So we know that 120 cubic meters is equivalent to the length that we have been given is 8 meters, and then the height is 5. So it means that we'll be able to have 8 times 5, then times the width, which we don't have. So meaning that when you do that, you'll be able to have 120 cubic meters is equals to 8 times 4. Sorry, 8 times 5 is 40 times W is 8 W meters cubic. So for us to get the meters square, so in this case, for us to get W, so we are going to divide by 40 meters square divided by 40 meters square. So therefore, when you cancel this one here, you remain with W is equals to meters and meters. We cancel here. Since the meters is square, this one will remain 1 meter here. Therefore, 40 goes to 120 3 times. So the width will be equal to 3 meters as your solution. The same case with the number 4. 1 liter of milk is poured into a cylindrical container of radius 10 centimeters. Calculate the depth of the milk. Yeah. So we look at the second part in number 4, which says that 1 liter of milk is poured into a cylindrical container of radius 10 centimeters. Calculate the depth of milk. Who can give us an idea on what does that question require us to find? Yes. Sorry?
Is it the volume?
It's not the volume. The question says that calculate the depth of the milk. So in that case, what does that question mean, or what are you required to find?
Height.
The height. Very good. So how are we going to do or to go about it? You can explain. How are we going to go about it?
I think we shall first change the liters into centimeter. The
Yes.
liters in centimeter. Then, being given that we have the volume as 1 liter, we equate with the formula of, I mean, using the formula of finding nini, tutatumia pi r squared to equate na nini na hiyo volume yake. Pi r squared height to find the volume. Area over volume, pi r squared height. So we shall equate your 1 liter ambayo tutakuwa tumechange into centimeter, then to find the to find your depth, to find height yake.
Yeah, that's very correct. That's how we will be able to go about it. So the first thing is to change the capacity that you have been given into centimeters cubic. So you change it into the volume. So whereby we already know that the conversion unit we have here is 1 liter is equivalent to 1,000 centimeter cubic. And then we have been given the radius of the cylindrical container of 10 centimeters. So therefore we know that the volume of a cylinder is given by pi r squared h. So since we already have the volume, which is 1,000 centimeters cubic, will be equal to pi is 22/7 times the radius, which is 10 squared, then times the depth, which is the height we don't have here. So therefore, meaning that for us to get height, we say height will be equal to 1,000 times the reciprocal of 22/7 is 7/22, then times the reciprocal of this one, which is 100. So the reciprocal of 100 is 1/100. So therefore, it means that this 100 goes to 1,000 10 times, and then we're going to have h being equal to 70 all over 22. So when you simplify that, you can express it as a decimal, or you can give it as a fraction, whereby as a fraction it will be 22, that is 3, and 4/22, that is 3 and 2/11 centimeters. Or you can be able to express it as a fraction, and you give it into 4 significant figures. So are we okay with that?
Yes.
Yes.
Yeah, good. Thank you. Then yes, we have question 7. Can you look at it? Question 7, which says that how many kiloliters of water are there in a full rectangular tank, 4.5 meters long, 4 meters wide, and 2.8 meters deep. So when you look at that question, it's a question that involves a cuboid, whereby you have been given the length, the height, and the width of that cuboid, and then you are required to find how many liters of water. So in that case, it means that you are supposed to have the capacity of that container. So the first step for that question is first find the volume of the cuboid using the formula, whereby we use the formula length times width times height. Then from there, you convert the volume that you have gotten into liters. Then from liters, you can be able to convert it to kiloliters. And that one becomes your final solution to such a question. And then number 6, a rectangular measures this by this, the capacity in liters. That is also simple. And then number 8, a school water tank has a radius of 2.1 and a height of 450 centimeters. How many liters of water does it carry when full? The same case, you find the volume. Since this one is a cylindrical container, you use the formula, which is pi r squared h. But remember, in this case, you have been given the radius in centimeters, in meters, and then the height in meters, centimeters. So you have to make sure that the units are the same. Either you have them in centimeters both, or both of them to be in liters. So I think that one is well taken, unless there's a question from anyone among us, because I want to handle something else which is still related to this one in the next topic. Is there anybody with a question on volume and capacity?
Tutafanya more practice, teacher. I think that
Sorry? Sorry? I'm not
we
getting you
shall
well.
do more practice. Yes.
I don't know. You are breaking. I can't hear you well. Can you please type? I guess since we had our class starting at 8:30, for us to cover 2 hours, we had to move to 10:30. Then the next lesson we start at 11. So I wanted to introduce this next topic as we are waiting for your message. Okay, so you are suggesting that we do more practice on capacity in individual levels so that we can be able to get it. So I stop introducing this next topic because it's somehow a concept that is almost similar to what we are doing on capacity, because it's on mass, weight, and density. But if you think you need to have that, I have so many questions here on the same, which maybe we can have a look at some. Let me check whether they are available. Yeah, I have so many questions here, which maybe
Teacher,
I will share with you later. You
teacher,
use them to practice. Yes.
yeah, I just wanted to help Maura on
Yes.
the same topic, as in I wanted to tell her the most important thing to the questions. One must read the question and understand the question, if it's about a cylinder, or is it a cuboid, or is it a cube. Then from there you can able to relate what we have learned with the formula. Then she can try several questions, send them to you, and check if she's on the right track while you introduce that new topic. Because I think we have read it for almost 4 hours now, the same topic.
Yes. So I was thinking that we need to introduce the next one. So because I already have so many questions here, I will share them with you. Then you will be able to use them to practice in case you encounter any challenge along the way. I'm readily available to assist. You can send them to me, or you can also be able to request so that I can be able to show you on how to go about them. They they will be able to assist you so that you get what is right. They aren't something that would challenge you much, but in case of any problem, you can be able to seek for assistance from any of us. So allow me to just introduce this next topic, which is on mass, weight, and density. It borrows much from this area that we have covered on volume. We are going to have to relate the two because you will be required to find the density whereby you are using the volume. So in simple terms, we can say it's a continuation in this case of the same thing. Yeah, so therefore, under mass, weight, and density, we will be required to do the following. Starting with the mass, mass is a basic unit or a basic quantity whereby it's a quantity of matter in a certain object. And its SI unit is usually in kilograms, meaning that it's measured. The standard unit that is used or known universally is kilograms, but there are other units which are also used in this case. Like, for example, we know that one of the units that can be used is kilograms. Then the other one we also have can also be measured in grams. Then the other units that we can be able to use apart from these two, the two are the ones which are common. And then on top of it, we have the other one which is tons. It's another one which is the common units that are used in determining mass. Though there are other units which are used like milligrams, centigrams, decigrams, decagrams, and hectograms are also the ones which can be used in finding or in measuring mass. So therefore, it becomes much easier once we know how we can be able to convert these units from one to another. Excuse kidogo tu. Yeah, sorry. I was saying that in this case, we can be able to use these units and they can be converted. The same case here, we can still use the same method that we talked about in identifying those units of measurement, whereby we see that we can be able to have it in kilograms, hectograms, decagrams, grams, centigrams, and so on. So for this one, since the highest or the one that we can be able to refer it to is kilograms, and it's at the top here. So therefore, it means that we can be able to have it as K, H, D, G, then again D, C, and M. These are the basic ones, whereby we can be able to have this one as kilograms, then this one is hectograms, decagrams, then this other one here is grams, then decigrams, centigrams, then milligrams. Then we can also be able to add other ones, which are micrograms, which are denoted by this symbol, micrograms. Then we have megagrams, and lastly we have tons. So for this conversion, we'll be able to start kilograms at the top here will be 1. Then as you move downwards, remember we said that for those ones which are downwards, they will be in decimals or 1 all over. So this one will be 1 over 10. This other one will be 1 over 100. This other one will be 1 over 1,000. Then 1 over 10,000. Or as we had mentioned earlier, that this one can be, instead of us comparing them to kilograms or equivalent to kilograms, we can be able to have it such that we reference it to 1 kilogram. So therefore, at that point, tunaweza amua, instead of us having that one there, we can say that 1 kilogram is equivalent to 1 kilogram at the top here. 1 kilogram is equivalent to 1 kilogram. Then on the other end, we can say 1 kilogram is equivalent to 10 hectograms. 1 kilogram also is equivalent to 100 decagrams. Then 1 kilogram again is equivalent to 1,000 grams. Then the other one is 1 kilogram is equivalent to 10,000 as you move downwards. So inaenda tu increase, but now once you get to this one here, actually it keeps on increasing that way up to micrograms, whereby this one here, 1 microgram is going to be equivalent to, 1 kilogram is going to be equivalent to 1 million microgram. Is it 1 million? 1, 2, 3, 4. Sorry, this 1 microgram is equivalent to 1 billion. That is 1 kilogram is equivalent to 10 to the power of positive 9, which is equivalent to 1 billion. And then this milligram is the one which is equivalent to 1 million. So this is equivalent to 10 to the power of 6. That is 1 kilogram. Then when it comes to megagrams, 1 megagram is equivalent to 1,000 kg. And also it's equivalent to 1,000 tons. So therefore that means that 1 megagram will be equivalent to 1 ton. So meaning that megagram is the same as tons. Since 1 kg is equivalent, 1 ton is equivalent to 1 ton, 1 kilogram, sorry. And also 1 megagram is equivalent to 1,000 kilogram. Therefore, it means that megagram is also equivalent to tons. So once you understand that table, it becomes easier now for you to manipulate these units from one unit to another, as we have already mentioned. For example, express each of the following masses in kilograms. 20 hectograms is equivalent to 20 times 0.1, which is 2 kilograms. So you can use this table as it is here, or the one that I have already shown you on how to go about it. Another example we can be able to look at is this one, number H, whereby we have it that we need to find express 39 megagrams into kilograms. So we know that 1 megagram is equivalent to 1,000 kilograms. How about 39 megagrams? So when you cross multiply that, you are going to have 39 times 1,000 divided by 1, whereby you get your answer as 39,000 kilograms. So that becomes the solution to that part. I think this one is more easier when it comes to conversion. You need to also note the symbols for each unit of representation. As you can see here, we have it that the megagram and milligram have the same symbols except for the presentation on them, whereby megagram uses capital M and G, and then milligrams uses small m and small g. The same case with decagrams and decigrams. For decagrams, we use capital D and G. And then we also use, for decigrams, we use small d and small g for us to represent them. So can you attempt part F? F, you convert or you express the following in grams. So for 892 hectograms, you convert it to grams. Let's attempt that. Yes, are we there?
Yes, we are doing it, sir.
Yes.
Yeah, we are trying to do it.
Yes, what have you gotten? In grams? Are you getting?
A minute, sir. A minute. Just a minute.
Okay, okay.
Mine, I'm getting it 10.2.
89.2. That's good. Domitila. Yes. So from that, you can be able to see that we have been given the value in hectograms, and we are required to find it in grams. So in that case, you will be able to understand that from this table, we can come up with the unit of conversion, whereby you see 1 hectogram will simply be equivalent to 100 grams. That is, if you are going to compare from this unit, since it goes up by 10, so therefore it means that you'll be able to have it as 1 hectogram is equals to 100 grams. How about the 892 hectograms will be equivalent to how many grams? So therefore, when you do that conversion, you will simply have it as 8,900 and, sorry, I mean you will be able to have it as 89,200 grams, because in simple terms, when you look at this one, if you use this part the way it is, you simply have it as 1 gram is equivalent to 0.01 hectogram. That's the other way in which you can be able to do it. How about 892 hectograms? You'll be able to give us what in terms of grams. So we'll be able to have 1 times 892 divided by 0.01, which is the same as multiplied by 100. Here to eliminate the decimals, multiply by 100 at the top also, so that your answer now becomes 89,200 grams. I don't know whether you are getting how this concept is done. Or the other way that you can be able to do it, if you feel like you can not be able to manipulate these units the way you need them, you can convert it to the standard or to the SI unit. Then from there now you can convert it back to the common unit. So for example, if you convert to the SI unit, we know that 1 hectogram is equivalent to 10 kilograms. Sorry. Yeah, we have it that 1 hectogram is equivalent to 0.1 kilogram here. how about 892 hectograms? So when you convert that one to kilograms, you'll be able to have it as 89.2 kg or kilograms. So now, since you already have it in kilograms, you can convert it to the next unit, which is now grams. So we know that 1 kilogram is equivalent to 1,000 grams. How about 89.2 kilograms? You'll be able to give us what? So it's 89.2 times 1,000. Sorry, times 1,000 divided by 1. So that now you have your answer in grams as 89,200 grams. I hope that one is now well understood. Is it? Are we getting that?
Yes, but do another one.
Okay. The other one, we can take part A of number 3, which is we express each of the following in grams: 4,538. So therefore, that one will be that we convert this one first to kilograms, then we convert it back to meters. So we know that, sorry, we convert it back to grams. So we know that 1 kilogram is equivalent to 1 million, which is the same as 10 to the power of 6 micrograms. So we already have this one as 4,538 micrograms. We convert it, or how can we convert it to kg? So when you cross multiply, you'll be able to have 1 times 4,538 divided by 1 million. So in that case, when you divide, you will simply have your answer as 0.00453 kilograms. Then from there, now you can be able to, now this one is easier to convert it to grams. So we'll be able to have 1 kilogram is equivalent to 1,000 grams. How about 0.00453 kg into grams? So when you cross multiply, you'll be able to have your final answer as 4.538 grams as your final answer. Sio imeeleweka sasa? Yeah. Now, because of time, would have wanted always to touch on weight, but I feel like we can stop there, then we will proceed in the next lesson. Unless there's anyone with a question. Kuna mtu ako na swali kupika hapo?
Nope, on my side.
Okay. Thank you for your cooperation. I'm going to share with you the questions on the same topic, though it covers both volume, capacity, mass, weight, and density. So you will be able to attempt them and then you share them, check and mark. Then in case of any change, feel free to consult. And then the rest of the other part that is remaining will be handled in the next lesson. Otherwise, thank you and have a good day.
Good day,
Good day.
teacher. Thank you. Thanks, weekend.